Well, I'm glad to hear that MPI is still going to be around for a while. Scali sells MPI. We're going to talk a little bit about performance in quad cores. We did a lot of recent benchmarking work on quad cores, both on AMD and on Intel processors. We're going to talk about some of the results there. But let's first of all, why Scali MPI? We are a commercial, established vendor and provider, and have been for a long time, of an agnostic MPI. There's other competitors from HP and Intel, but we've been recognized and have been a performance leader in HPC. It's not an open source product. We do charge for it, but we think there's value in the performance. It was written from scratch. It's not based on MPICH as most products were, and that gives us certain advantages, which we'll show you in real live application performance. Some of our major resellers include Sun and others. Some products in oil and gas actually have our MPI embedded in their products, the ISVs such as Schlumberger and Halliburton. We have resellers of the product as others and partners. We can see, you'll see us on the floor in some of the other booths during the show. But let's talk about the results of some of the work that we've done. These are published results using apples-to-apples comparisons where possible. And this is information that is very current, and some of this has literally been posted in the past couple of days. We posted the first quad-core spec MPI benchmarks last week on Barcelona. Unfortunately, there's nothing to compare it to in terms of spec numbers, but we'll show you some other application data. But let's start a little bit first with dual-core results. This is primarily on Intel on a variety of different platforms. We use LS-DYNA because there is that is one of the more common applications. It's supported on a lot of different platforms, and there's a website called TopCrunch which allows anybody to post the numbers using standard benchmark data sets. And in the work that we've done over the past couple of, probably the past 12 months, here's an example of some of the numbers. And what you see up here is a 64-core crash test. This is running something called Neon Refined Revised, which is one of the larger benchmarks that LS-DYNA uses. And the different numbers here are posted from SGI, Hewlett-Packard, and others. But the colors are important because these are the exact same hardware configurations using different MPIs. The top one from SGI, and once again, these are all 3 gigahertz dual-core Woodcrest systems. The top one, and in this case, the time is the key number. This is a Walcott time elapsed, and you see within 16 nodes, 2 sockets, 2 cores each. The fastest is which uses Scali's MPI from SGI. HP posted theirs using HP's MPI, and even has a faster interconnect, in this case the newest from Mellanox, ConnectX. Same application, once again, in green, is run the same data set but using Intel's MPI. So besides the performance numbers, you also run into scalability issues, and this is something we've focused on since day one. We've been able to scale very well compared to competitive offerings, and for the most part, most of the comparisons are to the other HPs and Intels in the world that are commercially available. And these are the first spec benchmarks. For those of you who are not familiar with it, spec MPI is an industry standard measurement of MPI-based application performance. And you can see across the board Scali's MPI with, once again, the same, in this case, 3 gigahertz Woodcrest systems has outperformed the competition. But in quad-core, the game changes. There are 2 key issues on core affinity policies, as we call them. This affects the application throughput on a system. Then there's also the notion of single node performance. The day of a 16-core workstation is here today, and it's only going to continue to get bigger as we go forward. Fluent, for example, half of their licenses are sold on single workstation systems. We're going to talk about something called you may know it as Core Affinity. We call it our Core Affinity policies that says you can map jobs different ways to a system. As an example, you have, let's say, 16 nodes, 8 cores per node, 2 quad-core sockets on a node. What policies exist? Well, you can map all of the whole job to all of the cores on all of the nodes. You can say run 2 jobs. One job is running on 16 nodes but on one socket, and the second job is running on the second socket. Or, once again, you can break it up and run half the job on 2 cores in one socket, or you can run actually the job just using half the socket and using the others unused. So these are the different options, and you find out that the way you map this affects the overall job throughput. As an example, you can see the first one, we're now talking in jobs per 24 hours, not wall clock time. So you can run one job on all of the nodes on all of the cores, and you'll get 150 jobs per day. So it turns out if you only use half of the cores, you actually wind up getting more jobs done per day. This is due to the local cache and the way the architecture of the system is. But in fact, you find out that if you go and run 2 jobs and run one job on one core and half the socket, well, on one socket and half the cores, the total number of jobs you get done in a day goes up dramatically. So pay attention to this. Our MPI has these policies, and you can set them before you run each job. This is why AMD, when they announced their Barcelona results, actually used Scali's MPI as some of the performance numbers. You saw this yesterday. Additionally, when you get into single workstations, an 8-core system, this is, once again, an LS-DYNA job, 3 vehicle collisions, you can see that the MPI, even within a single node, makes a difference. You can see that this, in this case, is elapsed time on the Barcelona with Scali's MPI, and if you compare it to MPitch and others, you actually get more throughput. Actually, even as of yesterday, this information was posted on TopCrunch. You see that, once again, the different MPIs affect the different performance. You look at some of the new, this was actually posted on the 8th. This is Intel's latest 3 gigahertz quad-core system. And even in this case, the Barcelona 2 gigahertz system on a single node outperforms Intel's 3 gigahertz quad-core system. So this information is what you need to know. Think about application performance at both a cluster level, the MPI is affected, and once again, the throughput is based on how you map the jobs to individual cores within a system. Any questions from the audience?